All right. Like I told you guys, in the National Electric Code, there are 3 circuits must know, or you don't belong to in the industry. Circuit number 1, when you do it in electrical code, circuit number 1 is the circuit that bringing the power to your building. Here's my building right in here. So this circuit is my service entrance. That's circuit number 1. Circuit number 2 is the circuit that brings the so-called the feeder. The feeder circuit number 2. Circuit number 3 is the branch circuit. This is range. This is called branch circuit. So important to understand this, Matt, because if you don't understand this concept, you always get confused. Every time there's a load calculation, every time, Adam, there's a load calculation that you need to do, you have to ask yourself, are they talking about service entrance conductor sizing, or feeders, or branch circuits? Can I just get you to understand that one before from the get-go? Because if you don't understand this one, you don't know where to use the calculation that we're going to be using now. Okay, so the calculation that we're going to be using right now is for service as well as for feeders. For service as well as feeders. So this table that we're going to be using, it's going to be sizing the service conductors here as well as the feeders. Can I just get you? With some exceptions, the branch circuit. With some exceptions, the branch circuits. Any comments, any questions, guys, about sizing? What is this table is doing? It's sizing the services, the conductors coming to your building, as well as the feeders distributing the power to your building, and applying a demand factor. If you have an apartment building, let's just say a 10-story building. Each story is an apartment. Do you think what's the likelihood that each and every one of them will be using his or her electrical range simultaneously at the same time, fully loaded? Not likely, right? So the smarter than you and I decided to have this table so they can derate. Meaning they take the sizes of the ranges in this apartment building and they cut it. Who cares? When you cut it, you reduce the size of the service that's coming to your building. You basically reduce the size, this size here. When you reduce the size of the service, as well as the feeders, then the equipment will be smaller, more realistic, cheaper, easy to install. So that's the whole idea of all these tables that we use in the NEC cookbook. Based on real experience and statistics, they discovered that, or they came up with these tables that allow you to have a smaller sizes because of what they call it diversity, the diversity of the load. Highly unlikely that loads will be used at the same time. Can I get you to understand that concept behind this table and every table in the NEC cookbook? All the tables, the rating tables in the NEC cookbook is based on the likelihood that people, when it comes to load calculation, are not going to be using the equipment at the same time. Okay, so that's the whole concept. So this table is going to be getting you what? You're going to be doing the branch, the feeders, and the service. This will be getting you the feeders and the service. And I'm taking snapshot at what I do here, and it's PDF and put in the network for you guys, for your review. Okay, so now that we know it's for the services and the feeders with limitation to the branch circuits, let's go ahead and see what this table is. This is, if you guys look at the top, it says the rating factor for household electrical ranges. So if you have a range, bring it on. How about wall-mounted oven? Bring it on. Countertop mounted cooking units, bring it on. And other household cooking appliances. Look at the size though. 1 3/4. Over 1 3/4. So that's the limitation. And the other limitation that you have to understand is the household right in here. So this is for dwelling. So if you are dealing with McDonald's, this is not your table. Can you see that word here? So if you have a range or an oven or counter-mounted cooking units, you can apply this table to it. Cool? As long as it's in a residential dwelling. As long as it's in a dwelling. Not Perkins, not McDonald's, not any of their fast food favorite Chinese. Um, did you guys understand the ranges that they use there? We take them at face value. Why? Because their job is to cook for you. Your house is not a restaurant, right? It's not meant to feed everybody. So there's a different diversity. If you have a restaurant, you're in the business of making food. So your ranges are fully loaded almost at all times, right? If you're an apartment building, highly unlikely that your range is fully loaded at the same time simultaneously for these 12 apartments. Everybody can see the restriction of this table, household. Okay, let's take an example. The example I'm going to take, I'm going to take a combined example, guys. Very easy. And let's take it right here. So here's my feeder coming in here and feeding a bunch of loads, right? Bunch of loads. I'm feeding a bunch of loads. Okay, from a panel, a bunch of loads. And all these loads are inside a panel. This is like, say, the panel that you guys are sizing with your friend Chad, right? And you need to size the feeder that feeds this panel. Let's just put the circuit breaker right here. The circuit breaker right here and bring it right here, okay? And we need to size the feeder. So everybody knows that this is a feeder, and these are the bottom ones here. And I want to go down to, just see if I can. There you go. Give it a little bit of a neck here. All right. Okay, so these are the branch circuits that we have. Okay, so I have an apartment building. Guys, taking a feeder into a panel and feeding 3 different ranges or cooking units or whatever you want to call them. And I'm going to give you sizes for them. The first size that I'm going to give, and we're going to do it right on here, I want to make, these are 3. Cool. And these are 5. These are 3 and these are 5. So these are 3 and 5. So I have 3 kW. Each one of these are kW, kW, kW. And these are, let's make these are 9 kW. To add salt to injury, I have 5 of these, 7 of these, and 3 of these. You guys have any issues with that? Instead of draw. So how many of them? I don't want to use 2 5s. Let's just use 4 so it can have different numbers. I have 4 of these. So I have 4 ranges, 3 kW each. I have 7 ranges, 5 kW each. And 3 ranges, 9 kW each. Right? 9 kW each. And I need to find the demand to size this cable. So what's your job? Your job as a designer is to come and size this cable and our connection device for this system. And then we'll do the branch circuit as well. Any comments, guys, about what we have? So we have a total of how many? 14 pieces of equipment fit from this panel. 14. Think of it as 14 apartments fit from this main panel. And we need to size the feeder for this apartment. Cool? All right, the first thing you guys, any question about what's given? Everybody knows what we're given here? We're given 14 pieces of equipment at different sizes, and we need to size. My job is to size, to size the feeder right here. I need the feeder, and I also need the circuit breaker. I need the feeder and the size of the circuit breaker. It's your job to find the feeder and the size of the circuit breaker. We don't do these for the mental exercise, guys. We do them at the end as designers to put it on the plant and size them. Okay. If you look at the columns, guys, let me walk you. So this is the system that we have. We're supposed to apply this table to it. So, by the way, this is an apartment building, so it's not Perkins. It's not Chinese restaurant. Okay. Here's how this table works. Can you guys see the first column says number of appliances. The second column, column A, says less than 3.5 kW. So before I go ahead and start with these guys, first, the default for this table is you take the number of appliances and apply column 4 to it. That's a default. So that's gig go. So look at this. It says maximum demand kW, not over 12. So you can use this table as long as not a single one of them is over 12 kW, right? Not over 12. I want you guys to review all these sizes at the top. Can you tell me if any one of them is over 12 kW? Do you see any one of them over 12? Do you see anyone over 12? No, none of them is over 12. So the default is always, you go, how many of them do you have? And what does C give you? One more time. The default is, how many of them you have, and what the C can give you if they are all 12 or less. Are they all 12 or less? Yep. Okay. How many of these babies do I have? How many of them do I have? If you add them all here, I have 14, right? Can you guys see I have 14 pieces of equipment? 14 pieces of equipment. All right, let's go all the way here to 14. Right? Why 14? Why 14? I have 14 pieces of equipment. Okay, are they all 12 or less? Yep, you're going to go to C. So for 14 pieces of equipment, what's my demand? Right here. So what's my demand? Can anybody read it? 29 kW. So kW, this column is kW. From the get-go, all this junk that you put on the board, all of them are going to be, all these junk is going to be 29 total. Done. Any comments, any questions, guys? Before we apply one more rule, though. So from the get-go, all of them less than 12, you apply that rule. All of them less than 12, you apply that rule. Okay. Any question about that? They're all less than 12. Add them up. How many of them do I have? 14. And go all the way to 29 kW. So, for all practical reasons, I can use 29 right now. By the way, if you add them all up, if you multiply 4 by 3 plus 7 times 5 plus 3 times 9, you're going to hit with a big number. Now you chopped it down to what, 29, because of the human being behavior. Highly unlikely me and my neighbor are cooking Thanksgiving dinner at the same time. Not just cooking at the same time. No, turning the knobs on an electric range, all of them fully, the range and oven at the same time. Now that's me and my neighbor. Now imagine 12 neighbors. The likelihood some of them will be out. So that's based on the human being behavior. By the way, utilities use this all the time, guys. They size based on our behavior. That's why when there's a catastrophe like 911, 9/11, and then the phone line jams. Remember how the phone line jams and all this stuff? Because people change their behavior. If there's something, everybody do the same. It's like a shower. Everybody going home at the same time. So it backs the roads. The same thing, the power system, the phone system, everything is based on us that we will not be using the same thing at the same time. Electricity is no difference. So that's why we use these diversity factor kit. Okay, now, any question guys about these? Your first question you're going to ask yourself, are they less than 12? Yep. How many of them do you have? 14? What's my demand? 29. Now, the second question you're going to ask yourself, does column A or column B apply to any one of them? Did you guys hear me? The rule first is you go 29. Now, the code allows you to go even deeper, lower than 29. Deeper, lower than 29. Did you guys hear me? Deeper and lower than 29. Cut. So then you're going to ask, after you get the 29, you have to go check something else. You're going to go say, okay, does column A apply to any one of them? Can you guys look at that? I have 3 kW. Is 3 kW under column A? Right? Right? It says less than 3.5 kW. So all these ranges, column A apply to them. Can I have thumbs up? Yeah, we understand that, chat? Okay. Then you go to 5 kW. Are 5 kW under column B? Yep. Right? So column B apply to them. How about the 9 kW? The 9 kW are not under any one of them, so I can't apply either A or B to them. So I have to apply C. Remember, the default is 29. Now I'm going to go see, can I get lower than 29? Can I get lower than 29? Okay, so let's go do it. I'm going to start with the first, I have 4. Here's 4. Can you guys see the 4? The 4, here's the percentage. Multiply this. I need somebody to do the math for me, please. Multiply the 66, these are percentages, by 4 times 3. Anybody knows why 4 times 3? I have 4 units. I have 4 units. Each one of them is 3 kW. And the code says if you have 4 of them, you can cut them by 66. How much? 7.92. 7.92. 2 agrees? Okay. So that will be 7.92 kW. Okay. So that's for the first 3. Why did I do that? Because some of these ranges are under A, so I have to apply A. I can, not I have to. I can apply A. All right, so let's go to the second. The 5 kW. How many of the 5 kW do I have, Adam? 7 of them. So I'm going to go all the way to 7. And under 7, this is my derating factor. Remember, that was my derating. You guys multiply the 0.66. These are percentage times. I have 7 of them, so 7 times 5. So do me a favor. Can you get me 40% times 7? 14? Thank you. 14 kW. One more time. What I did for the 7 of these, you go under B. Why under B? Because they're 5 and they are between 3.5 through 8 3/4. So you apply B. So I apply A on the ranges that are under A. I apply B on the ranges that are under B, right? Now, I'm going to go to this column here. Look at these, John. So, are they under A? The 9. Are they under B? So the only place I can apply these are under where? Under C. So how many of them do I have? I have 3. So let's go and find the 3 of them. Can you guys see? Here's the 3 of them. For 3 under C, what's the demand? Right from the get-go. Do I need to do math under C? Under C, no math is given, guys. This is C is KW. A and B are percentages. C, KW. A and B are percentages. Okay, so here's the 3 problems I have now. So I'm going to highlight them. I have with green. So I have this demand, and this demand for the 3 types of loads that I have. Add them up. When you add them up, so could you please do me a favor? Let's go 7.92, add it to 14.0, add it to 14, 35.92. 35.92. And what's the demand for 14 ranges within that one? Is 29. So which one are you going to size based on? The 29. Any comments, guys? Any questions? Any comments? Any questions? Yes, 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 absolutely. Yes, yes. You could end up, when you do them individually, lower than what C can get you most of the time. Did you guys apply 7 times 5 times 0.4? Like 0.475, that 14, you multiply it, right? Everybody came with 14? Yeah. Okay, so that's, everybody's okay. All right. So then, you have 2 numbers to use. Which number are you going to use? The lowest. So the size of my field is going to be based on this size. 29. The size of my feeder is going to be based on 29. Any comments, guys? Any questions? Any comments? Any questions? Why? Because of the likelihood that none of these will be up and running at the same time. Any questions before we move on? Let me repeat myself. You look at all your ranges and ovens and counter-mounted cooking units. Look at all of them. If they're all 12 or less, apply C from the get-go. Right? Very easy. I have 14 of them, all under C, give me 29. Done. Done. Step 1. Step 2. You're going to go check if any of these ranges are under A or B. Right? So, are they under A? Yep, they're all under A. So here's the under A. Apply A to the only the ones under A. Right, man? Can you see that we applied A to the only the 4, these guys? Because I did not apply them to the 5, because 5 is not under A. Came up with this. Then you go to this. These are under B, so we apply them 40% of 7 times 5, because there's 7 of them. Each one is 5. Get you this. Add them up. The third one is neither under A or B, so what you need to do for that one, because it's not under A or B, you're going to go take it under C. That's the only way you can get it. So you got your 9 under C. I mean, 3 of them under C got you what? 14. Add them up and choose the smallest of the two. Choose the smallest of the two. Any comments, guys? Any questions about the range? The smallest of the two. Okay, now when we size this service, somebody do me a favor. When you size the conductor, we need to size this conductor, so we came up with 29. So we need to find I. So 29K divided by 240. Why 240? Because the system is 240 volt. So divide this one by 240 and find me the amp, will you? 29,000 divided by 240. 120.8 is good enough. 120. 121. 121 amp. Right? 121 amp. 121 amp. Okay, then now 120 amp. These are residential. Do me a favor. I would like you guys to go to the table that talks about residential and size this service. So 121 amp. Take it to table, which table that we use to size the service or the feeder, which is 220. Okay, 310.15B7. 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 It's in page 153. So I have 121. My next standard is 125, right? So can you guys see that? 121. My next standard is 125. So this is 125 amp. So my circuit breaker here is 125 amp. Did you guys see that? My circuit breaker is 125 amp. The same thing from here. What's the conductor size? Let's use full neutral. 3 conductors. What's the conductor for 125 amp? Copper. Number 2. Number 2. AWG. Done. That's what you guys do. So we size the feeder. This feeder is number 2. The conductor. 3 of them. Why 3 of them? 2 hots and a neutral. We could derate the neutral. We could derate the neutral. They allow you to derate the neutral. Any comments, guys? Any questions? Any comments? Any questions? So that's using that table. 220. Okay. Any comments, guys, about these? Comments about this example? Comments, questions? So that's if, let me repeat this one because it has multiple things, guys. We have ranges under A, ranges under B, ranges under C. But all of them, though, C applies to all of them. If you look at, because they're all listed at 12. So the first thing we do is for 14 of them, we find the demand under C. Then we go apply A to the A, B to the B, C to the C, add them up, and see if we can come up with a smaller than what we started with, which is the 29. If we do, then we use it. If we don't, then we're stuck um, with what we have. Any comments, any questions? Any comments, any questions? So let me take a snapshot of this. So that's what we now I'm gonna erase this, guys. So we size the system. Okay. All right. So I size the system. I'm going to go just put the sizes here. Circuit breaker is already sized. So these are 3 conductors, number 2, right? That's what I came up with. 7. Okay, so I have 125 amp service, 3 conductors, number 2, feeding all these. That's the feeder. Let's do the branch circuits. Let's do the branch circuits. Right? How are you going to size the branch circuits? No, the branch circuits are going to size one of them at a time, guys. One of them at a time. And for branch circuits, let's start with the branch circuit, this branch circuit right here. So I'm going to call this one the 3 kW branch circuit. Here's how you do it. You're going to go to take 3. I need you guys to do the math for me. Divide by 240. Could you please? 3, 3,000 divided by 240. Now I'm sizing branch circuits. Branch circuit. At 12.5 amp, right? 12.5 amp. Okay, so what you're going to do is going to take it to 240.6. What's the next standard overprotection device for 12.5? 15 amps. 15 amps. Okay, and also for 15 amp, guys, what's the conductor from 310.15B16? 310.15B16. You need how many conductors? 3 conductors. Number? Anybody? 14 AWG. Done. That's what engineers do. That's what designers do. When we do math, I don't know if you guys sized it when you were in the electrical, but as designers, we don't just do the math. We size things. When we do the math, we size branch circuits and service. We put them in a piece of paper. We give them to the electrician so they can size it. They can install it. That's why I walk you not only how to do the math. You have to know how to do the math. Then you have to how to size the branch circuits and feeders. Okay, one more time. All these will be the same branch circuits, right? I mean the same type of branch circuits. So I have 3 kW branch circuit. You take them divided by 240. Why 240? We're burning them at 240. I know that. I'm telling you. 12.5. The next standard overcome protection device is 15 amp 310.15B16 under 60-degree column. What do you get? 60-degree column. You get 3 conductors, number 14. Any question? All right. So having said that, I'm going to go right here and write this is a 15 amp circuit breaker. And what conductor is these? These are 3 conductors, number 14. 3 conductors, number 14. All right, so let's do the second branch circuit. The second branch circuit, my friends, is, what do we call it? We call it the 5 kW branch circuit. All right, so let's take the 5. Who's going to do the math? 5K divided by 240 at 20.3 amps. 8? Okay, 21 then. And 21 amps. The same table will get you, you're going to go to the next standard, 25 amp. Circuit breaker, and from here for 25 amp, it's going to give you number, 3 conductors number. 12 cannot take you under 60-degree column. 12 are limited to 20. So that will get you number 10. So then this is 25 amp, and this conductor is 3 conductors number 10. Are you just following what I'm doing? Straightforward. So where did I get number 12? Number 10. Number 14. Remember what we said, number 14, you shall not put an overcome protection device more than 15 amps. Number 12, you can't put an overcome protection device on number 12 more than 20. Number 10, you can't put an overcome protection device no more than 30. So why do I have to go to 10 here, not 12? Because 12, look at my overcome protection device, my circuit breaker is 25. By the way, these little bulbs here are these. What we're sizing are these. These are what these are. I hope you understand. The circuit breaker, these are these. These are what we size. Okay? Yes, sir.
Are we still saying that on that one, the 5K KW, it has 7 of them?
No.
Oh, we just still one.
There is 7 circuits. Each circuit.
Oh, okay.
Yeah, there's 7 circuits. Each circuit is 25 amps. Did you guys hear me? Here, there's 4 circuits. Each one of these circuits is what? 15. Did you guys hear me? These are just branch circuits. Everybody understand that? Major concept. There are 3 circuits. There's 4 circuits here. Each circuit is 15. There are 7 circuits. Each circuit is 25. And now we're going to do the other one. Make sure. Does it make sense?
Yeah.
Okay. So, what was that? 3? Was that 3? I think it was 3. 3 of these. Okay. So that's the first thing we need to do. So we size our branch circuits. Let's go and size the rest of the branch circuits here. The last one. Okay. Now. Okay, so that's where. All right. So now let's go do the 9, shall we? Let's go to the, which color should I use? Let's use green for the 9. So this is 9kW. So do me a favor. Now, for the 9kW range, if it's a range, that's kind of a weird. I don't know how I'm going to put that one. If it's a range, which is 9kW's range, not counterclocking units or anything else. It's a range. Can you guys put range here? They allow you to use the table. For a range, they allow you to use the table for branch circuits. Only for range, not ovens, not counterclocking units, only for range. And by the way, all the stuff that I told you, all these rules are right at the bottom of the table if you read through the bottom of the table. Can I get you guys to understand, for range, you are allowed to use the table. Okay, so for a range, one range as a branch circuit from this table. Here's one range, and this range is under C, right? So what's the demand for it? Can you guys see it here, right here? What is it? 8. 8. So 8 kW. For one range, you are allowed to use the table for branch circuits. Now remember, we finished sizing the feeder. We're sizing branch circuits now. For ranges, they allow you to use the table. Did you guys hear me? You're allowed to use the table. Who told me that? The bottom. Read at the bottom of the table. It tells you for one range, you're allowed to use the table. Okay, so I used the 9 kW for one range, give me 8 kW. Then I size everything for 8 kW now. Okay, so let's go size everything for 8 kW. 8 kW divided by 240. Everybody knows why the 9 became an 8. Why did the 9 become an 8?
What note is that?
This is note number 4. it shall be permissible to calculate the branch circuit load for a range in according to table 250.55. Done. Okay, so can somebody give me an answer for this, please? 33.33 amps. Okay. What's my next overconduction device? 240.6. 35 amp. Okay. I'm gonna warn you a little bit here. I'm coming to a little bit here. Okay, so then, what's the conductor size? Everybody's going, know where we're going? 310.15B16. So when you go to the conductor size, 310.15B16, that will be 3 conductors, number 8. I'm not derating the neutral. 3 conductors, number 8. There's one little problem here. Not problem, an exception in the code. It says branch circuits, guys, if they are larger than 8 3/4, regardless, you cannot use less than 40 amp. So, with this exception, then this, because of the exception, I have to use 40 amp for this and 3 conductors. Number 8 still get me there, right? Number 8 still get you. Number 8. And this is from 210.19A3. 210.19A3. A3. It will tell you if your range is 8 3/4 or larger, regardless of what your calculation come up with, we don't want you to mess around and use this stuff 40 kW, 40 amp. That's why the 35 became a 40. Because of the exception. Again, sorry guys, I only explain the code, I don't write it. So, but the rule that you apply continue to be the same. It's cool, everything's cool, but there's an exception that says if your range is 8 3/4, which mine is what? What was mine? 9. 8 3/4 or more, regardless of what your calculation come up with, your branch circuit cannot be less than 40. Your branch circuit. So we were very close though. That's where this end up with 40. So I will have 40, this will be 40 amp, and these will be 3 conductors, number 8. 3 conductors, number 8. 3 conductors, number 8. Any comments, guys? Any questions? Any comments? Any questions? So what we did, now I have 14 circuit breakers in this panel. I sized them. 14 circuit breakers, and a main, and a feeder, and a branch circuit. Now, pick your tools, Adam, and get your conduits and start pulling wires, right? That's what we do as designers. Our job is to size all these branch circuits, feeders, and service. We're not just doing math for the sake of math. You know, we do the math to size equipment. The electricians depend on us to put something on a blueprint for them guys to go to install it. They will depend on you. Any comments, guys? Any questions? So we size the feeder. By the way, could be also a service to the building. Same thing, feeder or service, same size. These are branch circuits. See how we size it based on the actual load. We size it based on the actual load. Except if it's a range, you're allowed to use the code. And at the bottom line, you shall not go less than 40 if your range was 8 3/4 and larger. 8 3/4 and larger. Any comments, guys? Any questions about that? Comments, questions? Okay, I want to take one more example, guys. Any question before we go? Karen, does it make sense? If I give you a system like this, would you guys be able to handle it? Let me summarize one more time. First, we size the feeder. We size the feeder in 2 ways. Number one, we have if they're all under 12, you go to C and size it. Done. If they're all under 12, 12 or under, then you go check yourself. If some of them are under A or B, please apply A to the A and B to the B. And then the rest of them will be under C, apply to the rest under C. Add them up. Choose the smallest number. And then size your feeder. For branch circuits, nameplate value. We use the 3 kW like you saw here for all these 4, the 5 kW for all these 7 branch circuits. For the ranges, only if it's a range. If the 9 kW guys was an oven, you can't do this stuff. So only if it's a range. That's why I wrote range here. That's exception for ranges. If it's a range, then you're allowed to use a table. So here's a range, 9 kW range. Under one of them, give me 8 kW right in here. Can you guys see it? Right here. Then I start doing the branch circuit calculation for the 8 kW. I did them, 33, came up. I go size my overcome protection device and size my conductors because that's what we do. Overcome protection device, conductor. Okay, so that will give me number 8 from table 310.15b16 under which column? 60-degree column. Why 60-degree column for branch circuits? Because none of them is more than 100. But this one, I went to another table because it's dwelling. They allow me to go to the cheaper table, smaller sizes. Branch circuits you have, for branch circuits, guys, 310.15b16, done. That's it. Okay, so then I came up with these two sizes. But then if you go to 210.19a3 exception, it will tell you that for ranges, especially ranges in dwelling, you shall not use less than 40 amp branch circuit. Here's my 40 amp branch circuit. Would the number 8 still good for 40 amps? You go to the table 310 of 15b16. Yep, number 8 still good. Check, done. If that was number 10, then you have to up it to match the overcaptation device. Okay. Any comments, guys? Any questions about sizing branch circuits and feeders? Well, how about if this is a good time to give you guys a very quick break. I'm gonna give you a quick break, 5 minutes, and I'm gonna have one more example like this. Shall we? Everything that I'm doing here, Karen, will be PDF'd on the network. Okay? So it will be everything, all this junk that I do is a PDF to the network for you. Yes, sir. Can you wait until I'm done with that one, if you don't mind? Yeah, after the lecture, if you don't mind. Yeah, just take 5 minutes, will you? All right. Any comments, guys, before we take one more example? I have another example. You guys are designers. You're faced with this problem. The problem we're faced with is I have an 240 volt system. Guys, when I go through the calc, I don't know math, and if you guys, you have to write all this stuff. I'm going to be going over a lot of math as we go through the whole year. So I don't know if you're going to depend on my PDF file to download it, but it will go. There's a lot of math I'm going to go over the year, so just be aware. So I have 240 system. Here's what we have. All these are ranges. Can you guys see that? Remember, these are kWs, so don't forget that each one of these is a kW, kW, kW. So I have 10 kW, 15 kW, and 22 kW ranges. 8 of the first one, 7 of the second one, and 5 of the third one. So how many circuit breakers do you think branch circuits will only have? I have, that will have 16 plus 420, is that 20? All right. 20 circuit breakers, double pole circuit breakers in this panel. Plus a main. The main is going to be sitting either inside the panel or outside the panel. Your job, Adam, is to size the system, right? So our job is to size the system. So what I'm going to do first, I'm going to size the feeder, the 240 feeder that's coming to this panel. you're gonna get used to the way I do business, guys. Every time I draw these circuit, everybody knows that this box is actually a circuit breaker box, like the one there, the panel. These little bulbs are circuit breakers. The lines are represent a branch circuit down here and a feeder down here. Is it clear, the terminology? When I was in college, it took me a while for one professor to understand what he meant by what he draw. So, so we communicate at the same level, right? Ask me, what do you mean by this thing that you drew, Chad, right? You guys, we people hire us, Matt, because we're designers. These are going to be sizing the system for them, okay? All right, all of them. So look at this system. So let me ask you this. Look at the sizes. Are all of them under, is any one of them is under A or B first to start with? Is there any one of them size-wise under A or B, think KW 15 and 22? No. So forget about applying A or B to get from the get-go. Are they all not over 12? Are they all not over 12? No, they are more than 12. So if they're not over 12, then you're going to apply that rule down here. The rule down here is right, I'm going to highlight it right in here. If you guys read through this Mrs. rule, it tells you very simple. Can you see that rule? It says if all of them are, if all the sizes are 8 and 3/4 through 27, add them up, average them, and increase the average 5% for every kW, the average, okay, increase the demand 5% for every kW, the average is more than 12. One more time. If you guys read through this, it will tell you if the ranges that we have is over 8 and 3/4 through 27. Are we over 8 and 3/4 in size through 27? Are we? Yes. This applies directly to us. Step number 1. Anything less than 12, make it 12. Did you guys hear me? Anything less than 12, make it 12. Then average them. Then increase the demand that you get for all of them under C, 5% for every kW more than 12. Let's go do that. So you guys highlight that one. I'm going to go all the way, move this one away from me so I can do my math. There you go. Okay, so everybody knows where we got this information. So let's go and do this.
So here, first you want to take 10 moves 12, so do 12 plus 15 plus 22, and then take the average.
Yes, we're going to do it in a step. So first of all, how many ranges do I have here? All total, all together. Okay, guys? All together. 20 ranges. Okay, they're all under C, but there's one little problem though. Some of them are over 12. So, step number 1, the first step you do for 20 ranges, here's 20 ranges. What's the demand for 20 ranges? 35. Okay, so step number 1, I'm going to call right here. Step number 1, for 20 ranges, the demand from the table is what? 35 kW. Had all these ranges be 12 or less, we're done. Had all these ranges be 12 or less, we're done. But are they 12 or less? They're not. Some of them are more than 12, some are not. So that's step number 1. Step number 2. Add them up. You're going to add them up and average them. So let's go to the 10. Anything I'm writing in red. The 10 has to become 12. Don't ask me, KW. And then multiply this one by how many of them do I have? 8. And then I wrote it in red because it's important. Then the 7 times 15. I need somebody to help me here. 5 times 22 divided by 20. One more time. The note that we were looking at, guys, note number 2 says average them. But before you average them, Matt, you have to do the following. Anything, anything less than 12, make it 12. So that's where the 12 here, can you guys see that? It's the most confusing part of the whole business. So the 10 here became a 12. Why did the 10 became a 12? Because anything less than 12, make it 12. That's what note number 2 says. So instead of 10, I put 12 here. 8 times 12 plus 7 times 15, 5 times 22, divide by 20. Why? How do you average a couple of numbers? You add them up and multiply them by their number. Okay, I need 2 people to give me the answer, will you?
It's 311 is the total divided by 20. So
1 second, 300 and, yeah, the total. Yeah, I want the whole number, the answer for the whole thing.
15.55.
15.55, 15.55 kW. Do I have a second?
Yes.
Second. Good. So the average for all these babies is 15.55. Okay, from the get-go, if the average is a fraction and 0.5 or larger, it goes up. So this becomes what? 16 kW. Had this been 15.4, it becomes what? 15. 15.45, 15. 15.4, 9. Now I'm exaggerating. Anything less than 0.5 goes down, and it's more than 5, 0.5 goes up. Can you guys see? Okay, that's step 2. Step 3. Now, how far, step 3 is how far 16 is from 12. So you're going to take the 16 kW, the average, subtract from it 12 kW. Why 12 kW? This 12 kW has nothing to do with the system. This is from the note. It says, how far are you from 12? How far is 16 from 12? 4 kW, right? 4 kW. Okay? So the difference, how far is your average from 12? Okay? Then, step number 4. Take the 4 kW and multiply it by 5%. 5%. The 4 kW multiplied by 5%, that will get you 4 times, and you don't need the k here. All that you care is about the 4. The 4. 4 times 5 is what? 20. 20%. This is your increase. This is your increase. The last step is you take the demand, step number 5. What was your demand to start with, gentlemen and ladies? 35. Here's my demand, 35. Multiply the demand, increase the demand 20%. How do you increase the number 20%? Multiply that number by 1.20. Can somebody do 35 multiplied by 1.20, please? How much? Thank you. 42 kW. The demand for this system is 42 kW. The demand for this system is 42 kW. One more time. That's so important, guys, the steps I wrote it in. Very clear. Look at the sizes. Are they all under C? None of them is under A or B, right? Very clear. None of them is under A or B size-wise. Then, are they less than 12 or less kW? I wish they were. If they are, it's what? 35, done. Just 35. Don't need to do anything else. If they are not, then for the 20 ranges, give you 35 kW. That's their demand. But then now we need to up them. Up them by what? By the difference between their average and the 12. And for every kW difference, they want you to up it, increase it 5%. So the demand is 35 kW for ranges 12 or less, but they are more than 12 though. Then you need to average them. Anything less than 12, make it 12, average them. Then how far is the average from 12? Subtract 12 from 16. That's how far the average 12, 4 kW. For every 1 kW, the average is more than 12. Increase the demand 5%. That's what the language says. So we're 4 kW away from the 12. Increase it 5%. That will get you 20% increase. Then take your demand and up it 20%. 42 kW. Any comments, any questions? Any comments, any questions? Okay, so now that we did this, I'm going to take a snapshot of it. Now we know the KW. I'm going to go erase that one and size based on K and take KW. Okay? All right, so everybody, any question, guys, about how to do the demand? We found it. That demand for the feeder, not the branch circuit. The feeder. Can I emphasize the word feeder, not demand, not branch circuit? Okay, remember the 42, will you? So I want to go all the way here. Oh, okay, good. And I'm going to go right here. Okay, now we did that. Now we found our demand. Now let's go size the feeder, will you? Now I want to size feeder. Feeder size. Okay, what was the demand? Demand was what? What was it, 42? 42 kW. Then I need to do the calculation based on 42. Well, let me just say right here just for the sake of that. So 42 kW demand. A demand means you already chopped it and adjusted it and it's cool. Then you're going to find the amps. I equal 42K divided by 240 because the system is 240. Who's my math wizards? 42 divided by K, 42,000.
175.
175, do I have a second? 175 even? Wow. Weird, jackpot or what? Amp. Okay? Then, so that's step number one. Step number two, my friends, is you're going to take the 175 amp, take it to 240.6. Everybody knows when you go to 240.6 in the NEC code book to find you the standard overcapacity. Thank you. 175 amp. If you don't know that 175 is the standard, you're going to go to 240.6. It will tell you all the standard non-adjustable circuit breakers that we use in the US. 175. Okay. So then the circuit breaker is already here, sized. This will be what? 175 amp, 2-pole circuit breaker. Done. Go buy yourself a panel at 175. Now now we need to size the feeder, the wire here, right? The wire here. We need to size it. Then 3. So this is for circuit breaker. Now conductors. The same amp, guys, 175 amp. Take it to 310.15 B. Now this is, we go to the special table. Thank you, but we're going to go to the special table. Not, what was it, 15 B7? Is it B7? Can somebody give me the name of that baby?
Yeah,
B7. Okay, what's the next size? 1 aught. So we're going to use 2 conductors, number 1 aught. 2 conductors, number 1 aught. Why 2 conductors? Now the neutral, these are for the 2 aughts. They allow you to derate the neutral. Now we're going to go derate the neutral. Step number 4. I'll use it here. Step number 4. Neutral conductor. For neutral conductor, well, what you have to do is take 70%, multiply it by the size 175. 175. Do me a favor. What's 70% of 75? 175. 122.123 amp. 123 amp. Cool? 123 amp. Then 4, 5. Then so 123. Then again, then let's do it under the same thing. So you take the 123 amps, take it to, now you can take this one to the same table, 310.15 B7. What would you get? Number 2? Is this the next standard? Everybody's following with my friend here? Okay, that would be number 2. Number 2. AWG. How many of them? 1. So can you guys see how the code allows you to size the neutral slightly? So the 70% size of your neutral, because the neutral that's going to all these ranges is carrying the unbalanced current between the hot 1 and hot 2, and from knowing how the load act, it's not going to be carrying a full load. So they allow you to chop it from the get-go by 70%. Now, where did I get the 70% from? 220.61. Section 220.61, guys, tell you for ranges and dryers, you derate the neutral 70%. Okay, so now, have I said that? Now we're going to go down here and we say, here's our size. My size is going to be 2 conductors. Number 1, 2 conductors, 1 aught. Oops, there you go. So it's going to be 2 conductors, 1 aught, and 1 conductor, number 2. Number. So that's the size of my service coming to my building. Size me a pipe now. What did we do yesterday? Size a pipe. Would you be able to size an EMT conduit for this system? Absolutely, Chad. I hope so. Right? We walked you guys through how to size the conduit. Do you see why we went through the conduit yesterday? You're going to be sizing these conduits. Any comments, guys? Any questions about derating the neutral? Derating the neutral for the system. Okay. Any comments, any questions? So I size the feeders. I size the feeders. I need to go size the branch circuits now. I'm done with the feeders. Feeder sizing. We did the demand and we sized it. Okay. Now let's pipe it. Let's size the pipe. I'm going to use my calculator for that one. And you guys will do the math on that. Let's go size the pipe. Because that's typically what we do. We really end up with a pipe. Number 5, conduits. Conduit size. Let's go size the conduit. I'm using EMT. EMT. And I'm using and this is a feeder, and the EMT is the equipment ground and conductor. So we're not putting a ground with it. We're just putting 2 hots and a neutral, and we're using it as an equipment ground conductor. So I want you guys see how the math is going to be. So let's go directly into, okay, here you go. So remind me what the sizes are, right? It's, okay, except, all right, so let's go size it smaller, medium, okay. So clear. So here's what we have. We have 1 aught, right? Here's 0. 1 aught wire size. How many of them do I have? I have 2. What insulation? We're using THHN inside it. THHN, enter. Then I have 2 conductor 2 size, wire size. How many of them do I have? 1. What insulation? THHN. Click again. This is the total. We did this yesterday. The total square inches. Then conduit size, you hit the conduit. My conduit is an inch 1.25. Now go do it by hand, will you? So my conduit is going to be 1.25. Everybody can see that? 1.25. So I'm going to go close this one. All right, so my conduit, everybody see what we did? So it's going to be 1 conduit, 2 point, did they say 2.5? 1.25. I think I'm losing it. 1.25 inches EMT. In your case, guys, I don't want to go through the whole calculation. You know how to do the calculation that we did yesterday. You're going to go to table 4, table 5, add the square inches of all the conductors, then go from table 5, then go to table 4 and size your EMT conduit. Done. That's what you do. Is that what we designers do? Can we go size the branch circuits? As long as we're on it. Any comments, any questions about derating? Did you see how we did the derating for these feeders? After we derate, we size the overcap protection device as well as the conductors, including the neutral. Any comments, guys? Any questions? So I'm going to write the size of my conduit here, as long as I'm on it. So I'm going to say one conduit, 1.25 inches EMT. Done. Because I'm going to erase most of this stuff. Cool? Before I leave this, any comments about first finding the demand? The most important thing, guys, is to find the demand. So do me a favor. If you, let me just to give you an idea. Can you do me a favor and multiply 8 by 10, 7 by 15, and 5 by 22, and give me the KW? Add them all up, will you? Just do 8 times 311. Did you guys hear me? From 311 kW, I went down to how much? 42. Imagine, Matt, if you want to size the service for 311 kW. Just imagine. If you guys want to do through the exercise, put 311 here and size everything and see how big of a size of a service you're going to end up. That makes you appreciate these tables. Am I getting you guys to appreciate these tables? Cool. Let's go to the branch circuits. So we got the feeders. We're going to go to the branch circuits. Like I said, I'm capturing all the stuff that we do in PDF. All right, so let's go to a branch circuit. I'm going to go erase just to give me enough room, guys. I'm going to erase this. Leave the... Okay, one more time. There you go. Just there's the delay in the business. Okay, there you go, there you go. Cool. All right, now we size the feeder for the system. Now they're going to come up to you and say, well, what size branch circuit do I need for these babies, right? 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 Okay, let's go size it. Let's go size branch circuit. For branch circuits, I'm going to start with the first one, number 10. 10 kW branch circuit. Cool. We're going to size the 10 kW branch circuit. All these are ranges. All of them are ranges. So the code allows you for ranges to apply the table too, for branch circuits. The code allows you to apply the table. So from the same table, 220.55, we're looking at it right here. For 10 kW, one range will get you what? 8. Will get you 8. Right? Right? Am I right? It's less than 12, get you 8. Did we do through the 8 or what? We just finished, did the kW. So let's do the 8. 8 kW divided by 240. And can somebody give me the answer, please? 33.33 amps. And we're going to go to 240.6. That will get you 35. And also the table 310.15 B16 will get you number 8. Number 8, and we said because there is restriction on this size, it has to go 40 and what? And number 8, 2 conductors number 8. 40 and 2 conductors number 8. Now, 2 conductors number 8. I'm going to size the neutral conductor. For neutral conductor, guys, they allow you to take 70% of the 33.33. Can you guys give me a 70% of 33.3, please? How much? 23.33. Thank you. 33 amps. And then you take the 23.33. Take it to table 310.15 B16. What would that give you? One conductor number? Number 10. You can't go number 14. Under 60-degree column. 60-degree column, not one conductor, right? Did you guys go 310.16? Yeah, number 12 will get you 20 amps. So you have to go through number 10. Number 10. Now see how now I end up with how many conductor sizes. This is supposed to be 2 here. So now I'm going to go right to this baby here. and put a 40 amps, and the conductor size is going to be two sizes. This will be 2 number 8, and one conductor number what? Number 10. Oh, by the way, the DC code book tells you for branch circuit and feeders, you can't go less than number 10. So if I came up with number 10, less than number 10, for the neutral, I can't go less than number 10. I have to use at least number 10 for the neutral. In our case, we came up with number 10 anyway, so we don't have to. Had I come up with a 12, they don't allow you to do the ranges. You have to go minimum neutral number 10. That's why when you get into the neutral cables, guys, you can find two conductors, the hots are big and the neutral smaller, slightly smaller, based on this calculation. Am I the only one who's excited today? Okay. So that's the size for this range. Any comments, any questions? The first range, we did not do the neutral derating because I don't want to confuse you, but we should have done a neutral derating. Always neutral derating for ranges, always, 70%. Magic number. Where did it come from? 220.61. If you go to 220.61 section, it will tell you your derated ranges neutral and the dryers neutral by 70%. What? This one for any neutral, as a matter of fact, for ranges, for it doesn't apply to I don't think it's good question. I always apply. Can you guys look? I don't think there's a household ranges. Okay, go to that one. Read it. I can't remember. Okay, here, prohibited. Okay, a feeder supplying. Aha, there is a household. Yeah, you're right. There's for ranges in household electric ranges. You're on. Household electric ranges, 70%. Household, yep. The dwellings. I never paid attention to that one. Thank you. I always thought I always apply it to residential, but yep, it's household for what we're doing. Okay, let's do another range. So the second one, will you? The second range, what was the size of the second range? There's 15 kW. 15 kW. Okay. Now, Karen, for 15 kW branch circuit, the code allows you to use the same table for branch circuit ranges. Okay, so the same table, what's the demand for 1 kW under C? 8 kW. Did you guys hear me? 8 kW. Hold your horses. Hold yours. Hold yours. Now, we're sizing the branch circuit for that 15 kW. There's how many of them? There's 7 of them. But we don't care how many of them because we're not sizing a feeder. We're sizing just home runs for each one of them. Okay, the code says for branch circuit, apply the table. No problem, ranges. Okay, is the 15 kW less than 12? No. So the demand under C is 8, but because it's not less than 12, had it been less than 12, we're done. Because it's more than 12, you need to up this number 5% for every kW. For every kW, the demand is more than 12. Okay, that's step number 1. Step number 2, guys, is you're going to take 15 minus K minus 12. That will get you what? 15 minus 12, 3K. That's the second step. The third step is you take the 3 and multiply it by 5%, and that will get you 15%. Wow, how did that go? Oh, I can't miss with that one. That will give me 15K, not 15, yeah, 15%, not 15K, 15%. And then my demand here have to be increased by demand 8. I have to demand this 1.15. Did you guys see it? For a range, they allow you to use okay, there you go. I'm gonna go get that one. Here you go. So you take the 15, what did we say? 3, multiply this one by 5%. That'll get you 15%. What's 8 times 1, 1.15? 9. 9.2 kW. Ladies and gentlemen, now we're going to size everything based on 9.2. Any comments, any questions, guys? I can't emphasize. For branch circuit, you can apply the table. You can apply the table. So now, the rest is history. Now, what you're going to do, now you're going to take the, which number now? The 9.2 kW divided by 240. Can you guys do that for me, please? What's 9.2 divided by 38.33? Take this one to 240.6. What would that give you? 40 amps. Same calculation. Take it to 310.15 B16. That will get you also a number 8. Two of them. Two conductors number 8. Two conductors number 8. Right? Two conductors number 8. Now let's do the neutral. I'm going to make myself a little bit of room here. The neutral conductor, guys. For neutral conductor, what you're going to take is 70%. Do me a favor. 70% of multiplied by 38.33. Can somebody give me the math for this, please? 26.3 amps. And then for 26.3 amps, that will give you one conductor number 1, number 10. So my neutral is number 10, one conductor number 10. Which table? 310.15 B16. Which table? 310.15 B16. Any comments, guys? Any questions? 310.15 B16. So let's go and put all this stuff again here. This also end up with, believe it or not, 40 amps. And the conductor also end up with number, same size, right? Two conductors number 8. So this end up with 2, number 8. And the neutral was 1, number 10. One number 10. Same size. Look at that. They're different sizes, 10 and 15. They end up with the same size circuit breaker. Same size circuit breaker. Same size circuit breaker. And the same size neutral and the same size conductor. Based on the derating. Any comments, guys? Any questions? Any comments? Any questions before we go sizing the branch circuit for the last one? The branch circuit for the last one. If I give you this on a test, would you guys be able to do it? Handle it? Something similar? Okay. I'm going to size the pipe too. You guys have to be able to size pipes, right? Since both of these are the same size, I'm going to do the pipe before I erase this. I'm going to do the pipe somewhere. So I'm going to do my calculation. I don't want to. I'm going to go the size, grab my calculator here, and you guys will do the pipe the regular way. I'm going to go my pipe. Here's my accept. I'm going to go size the pipe. I'm going to pipe it medium. So we're putting him in a pipe. We don't have to put in a pipe. That could be, you guys could have bought an NM cable and wire with it, or a C cable and wire with it, and done. But let's just say if we're going to wire it in a pipe, what was the size number 8? I have 8, number 8, wire size. How many conductors? I have 2 conductors, THHN. Oops, what did I do here? Here's my 8, wire size. Copper, everything is copper. 2 conductors, THHN. Okay, and I have number 10, wire size. And what? How many of them do I have? 1 conductor, and the insulation THHN. And you have to click again. That will give you the total. The first click give you the cross-section area of one of them. The total, it adds it up. And then you click here and get you a 1/2 inch. You could have said that from the get-go, 1/2 inch. Okay, so did you guys see that? So now I'm going to go pipe it. So my pipe is, for this one, is going to be 1.5 inch EMT, and this one is going to be also 1.5 inch EMT. So I piped it with half an inch EMT. They're the same size. Any comments, any questions for the branch circuits? Any comments, any questions? The last thing I want to do is the last branch circuit. Capture. Yep. No. No, there are two different sizes. You can't use this. Did you use a math?
Yeah, well, that's why I said 0.64, because it's 0.164 and then 0.216 times 2, and you get like 0.596 for a total diameter.
You add them up and you came up with different size?
Well, 0.596, that's what I got.
I can't remember what was the total on the calculator. Yeah. Check that one, will you? No, you have to use a 40% fill.
Yeah.
This is based on a 40% fill. 3 conductors. Okay. Let me. You guys will check the size in the pipe. Let me. And I would like you to do that. Let me do the last branch circuit. The last branch circuit, guys, is for the 22 kW range. From the get-go, you're going to apply the table 220.55. You're looking at it. What's the demand for a one range 22 under C? 8, the magic number 8. Did you guys see that? 8 kW. From the get-go. Now we need to go ask ourselves, how far is the 22 from 12? So step number 2 is you're going to take 22 minus what was it? Minus 12. That'll get me 10 kW. Step number 3, 10 multiplied by 5%. That will get you me 50%. Step number 4, then you take the 8 and you multiply it by 1.5, and that will give me 12, right? 12 kW. 12 kW, right? Am I right? 1.12 kW. That big, fat, fluffy 22 kW now is seen as 12 kW in the system on a branch circuit. Do you guys see that? Okay, so let's go ahead and size the 22. So that's the demand. That's the steps that you have to do the demand. So let's go branch circuit. So now you're going to take the 12K and divide it by 240. Who's my math wizard?
50.
50? Thank you. 50 amp. Wow, what's with the size? 50 amp. Okay, then you're going to take the 50 amp, take it to 240.6. That will get you also a 50 amp circuit breaker. That will give me a circuit breaker. And then take the 50 amp to 310.15 B16 because it's branch circuit. That will give me 2 conductors. Number 1. Number 6. Thank you. Number 6. The last thing is neutral. Neutral conductor. What do you need to do with the neutral? 70% times 50. What would that give you guys? Thank you. 35 amp. Take this one to 310.15 B16. That will get you number 8.
Yep.
1 conductor, number 8. 1 conductor, number 8. 1 conductor, number 8. Okay. Now what do we have here? We have a 50 amp branch circuit. The conductors are 2 conductors, number 6, with 1 conductor, number 8. The last thing left is a pipe. Let's go pipe it. The last thing is a pipe. Let's go pipe that boy. And so let's go, and you guys will do the piping. So what did we say? Did we say number 6? Okay, let me number 6 wire size. Oops. Click on 6 wire. There you go. Just need oomph. Number 6. How many of them do I have? I have 2 of them. Here's my wire size. Click on it. Cool. And then the last thing is number 8, right? Number 8. How many of them do I have? Here's number 8. How many of them do I have? 1. And same thing, THHN. Click on the, is my total. And here's my conduit size. 0.75. Probably, if you give it to an electrician, you could have probably look at it and say 0.75. So that would be 3/4 of an inch. So it's going to be, the inch is going to be 3/4 of an inch EMT conduit. How many of them? 1. As designers, Adam, it's not enough. And I want to warn you from now moving on, Karen. When you guys write something for me, if you say 3/4 of an inch EMT, it's not enough for me. You need to tell me how many of them. You're going to be taking off this project. It's not enough to say, what size conductor? Well, it's 4/0. How many? I can have 4 4/0s, or 2 4/0s, or 1 4/0, right? In the design industry, it's not enough the answer to be just 4/0. No, how many? Very important. So when you get size this is how I'm going to tell you. It's a 50 amp 2-pole circuit breakers. Why do I know it's 2-pole? 2 hots, 240. That's the only way you can get in the US 240. Is if from 2 hots. If you're in England, you can get it from 1 hot. You know, 240, 50 amps, 2-pole, and the conductors are 2 conductors number 6, insulation THHN, 1 conductor number 8, insulation THHN. The conduit is 3/4 of an inch, 1 conduit EMT. That's the complete description that you put on your plans. That's what a good designer do. Can I get you guys in this habit? When you size that, you're going to be sizing the same thing for me, for the project. That's what you're going to be doing. You're going to size, first size is for the phases or the hots, then neutral, then the conduit right underneath them with an overcompression device. Now, you can give it to well-qualified journeyman electrician, give him this information. He or she should be able to go grab a 50 amp 2-pole circuit breaker Q or QP, whatever the manufacturer is, plug it in there, put a pipe of 3/4 of an inch up, tighten it, pull it to wherever this device is located, to a junction box. From the junction box, pull the conductors. There they will have a plug there. Put that plug there, wire it, and that will be ready to be plugged into that equipment, right? That's how we design a system. Any comments? And this is residential. This is nothing. We're going to go moving into, you walk into a manufacturing floor and you have a machine that sucks 200 amps out of the system. And you are supposed to size the feeder that feeds this machine or the branch circuit, right? Same concept. Always show the pipe, the wire, the overcompression device for this equipment. Any comments, guys? Any questions? Any comments? Any questions? So these are all the scenarios, guys. We size branch circuits. Let me take a snapshot of it. We size branch circuits. We size feeders from this table. The only thing that left is really some. We have keynotes. Some kind of monkey math here. I call it the monkey math. I'm going to get you guys into just do the monkey math. One monkey math. We covered all the scenarios that this table do, except the monkey math at the end. So we'll go. All right. So let's just go erase the whole thing here. Now, I don't want to do the sizing the branch circuit, but if you go down at the bottom of this table, guys, there's what I call it monkey math. And you have to do math to find the rating factor. Go down at the bottom of this table. Look here, right here. Can you guys see that? I'm going to focus on these two. In order to find the demand, you have to do some math. Okay? So let's take one scenario, easy to use. Let's say I have a system. I'm just going to apply the math here. Let's say I have how many of these? Let's just say 35. Okay, 22, 35. Let's have 35 ranges. Each one of them as 11 kW. Right? 35 ranges, each one of them is 11 kW. Find the demand for these babies. Okay, can you guys go at the top? Are these 11 kWs, 35 kW, 35 ranges, 11 kWs, are they under A or B? No. They're all under what? C. So from the get-go, the demand for these is the following. We are right in here, 35. So we're going to use this demand. Let's apply this demand. This demand says the following. It says 50 kW, okay, plus 1 kW for each range. 1 kW minus, okay, for each range. Okay, so 15 kW plus 1 kW for each range. That's it. So the demand is 15 kW plus 1 kW for each range. So multiplied by 35. Do you guys see how you interpret this math? 15 kW from the get-go plus 1 kW for each range. How many ranges do I have? 35. So basically 15 plus 35 will get you what? 50? 50 kW. Demand. I do not want to do the math on it now. You guys can go on size for 50 kW. All your sizes will be based on 50 kW. Can I have thumbs up, Chad? We know how to find the demand here for these 35 ranges. Okay, so now it's an example. These are all ranges. All right, so now let's take another example that right underneath. Let's say I have 70 ranges. How the heck would you have a 70 ranges? Can anybody tell me, how would you have a 70 ranges? Can any house have 70 ranges? No. Can an apartment building have 70 ranges? Yes. 70 units, 70 ranges, all will be seen by the service at the bottom of the building, right? All of them are going to be sucked from the service. So when you size a service right at the bottom of the apartment building, that's, say, a 24-story apartment building, with multiple apartments in every story. When you size a service to feed it, that's what you do. Any comments, guys? Any questions about that? So that's 70. Now I want to use my demand factor. So let's assume that all these are the same thing under C. So let's say each one of them is 9 kW. Okay? From the get-go over 61, I'm going to use this. Okay, so let's apply that rule. How do you apply that rule? 25 kW plus half, is it half or a quarter? A 3/4 for each range. There you go. So 3/4 times each range, which is 70. So what is 3/4 of 70? Plus 25? 77.5 kW demand. So when you size your feeder for this apartment, the load allocated to the ranges will be demanded to 77.5. Now when you size a feeder for an apartment, do you think the only load on this feeder is just ranges? Of course not. When you reach the ranges calculation, which you guys are going to be doing load calc for me soon, when you reach the calculation for ranges, that's what you do. Then there's calculation for receptacles, calculation for lights, calculation for pumps, and so forth. But this is directly related to the ranges. When they say, you're going to look at your loads, oh, I have ranges, so I have to go to range calculation. I'm plug them in. I'm done there. Now I have to go to lights. Here's a calculation for lights. Plug them in and add everything together. And I'll walk you through how to do calculation for the apartment, step by step. But when I reach the ranges, I'm not going to repeat this one. I hope when I say, here's how we do the calculation quick, hopefully we focus 2 hours on that. Um, Hopefully you know why we demanded it faster. I go over it fast. Um, but everybody knows why we focus these 2 hours just on the range calculation. On the range calculation. So for all practical reasons, now your feeder or your branch circuit, as a matter of fact, or your service, because they're ranges, will be based on, in this case, will be actually services and feeders, because services and feeders will be based on this. So I'm going to go right next to these. These loads will be what? Service and feeder. Everybody knows what a service conductor coming to the building. Feeder from panel to a panel. For branch circuits, this is the number that you're going to be using for branch circuits. The number you're going to be using for branch circuits, basically, for each 9 kW, you're going to be using for branch circuit. Here's a 9 kW. 9 kW right here. So 1, number 8. That's for branch circuit. For what's the other one? The other one is 11 kW. For 11 kW, 1 under C8. So both of them will be 8 as a branch circuit. But as a feeder, will be different. Any comments, guys? Any questions? Everything that I have told you about is written right at the bottom of that table. Right at the bottom of that table. Any comments, guys? Any questions? Comments, questions? If I throw a range calculation for you guys, it will be a range calculation in the test. Couple of ranges, put it together. So it's let me take the snapshot and then summarize, and I'll let you guys go. So what I've done, guys, with you, we took 2 hours almost. Talk about very, very important table in the NDC code book. Before I let you guys go with this one, I'm going to go back again, summarize. This table is used for dwellings only, ranges, ovens, and counter cooking units. Counter-mounted cooking units. It's used to size mainly feeders and services. Branch circuits are allowed to be using this table only for ranges. The default is C. You apply A, B, or A only if the range or the oven or the cooking units is under any of these columns. Otherwise, your default is where? C. If you are more than a C, then you have to start all of them the same size. Take the demand under C and increase 5% for every kW you are more than 12. If they are different sizes, then you average them and find how far is the average from 12 and increase the demand 5% for every kW the average is more than 12. And size your feeders. When we size the feeders, guys, we can go to 310.15 B7 because that's a dwelling. When you size the branch circuit, you have to go to 310.15 B16 because we don't size branch circuits based on B7. So that's basically the whole table. This is from chapter 20. There's a couple of examples at the end of chapter 20. You guys can practice it. Any comment, guys? Any questions? Comments, questions? Make sense? Too much? Yes, no? Adam, did you guys do the same thing when you more or less indifferent? Yeah, you can see we focus on the design more than just the math for the math. Every time with me, guys, when we design things, we're always going to draw a line, one line diagram and size, because we're interested in sizing. We're not interested in just math. Yeah, bottom line, people are looking up to you or looking to you to come up with a size for these equipments, right? That's what they pay us to do. And I know, guys, some of you, especially the ones who You haven't seen these tables, but you don't have to. I mean, the assumption is this is the first time you ever seen this table. That's it. That's my assumption. I go over it as if you have never seen this table. Is that enough, Matt? Does that make sense? Derek, my friend, is that good enough? Okay. So we're gonna work on our power. Are we good, guys, to power? Do power. So what I'm gonna do, guys, tomorrow, then I'll take an hour or so and I'll review for the test. We'll go over it because the test is gonna be on Friday. It will have a range, and I will go over range example one more time for you. But it has conduit fill, box fill, um, calculation-wise ranges, and amplicity derating. So I'll walk you through step by step how to focus your mind on the calc that we do. Cool? Thank you.